Okay, so the code for this one is EGR. So there's the code error there. It's a EGR to this one. So the lab procedure, you know lah. Main thing is to stay safe. And if you need to wear PPE, personal protection equipment, then you need to wear lah. Okay. During your lab work, please wear cover shoes lah. Okay. Normal lecture, you can wear anything that you like. But if you go to the lab, then please wear cover shoes. Okay. So that is the thing. So every time you will see learning outcome. So how does this learning outcome help you in this module? So in this module you have test, exam, and report and lab, right? So each one of these will come out, like for example, learning outcome number 1, number 2 will come out in your test 1. Then your test 2 will be CL3, CL4. Learning outcome 3 and 4 will come out in the test 2. Then your final exam will be cover 1, 2, 3, 4. So you will go in that way. So for example, CL1, I highlight all the important things. So test 1, question 1 will ask you about crystal structure and diffusion. Okay. The question 2 will relate to metals, mechanical properties, yeah, all this. So as long as all the equation related to all these highlighted keyword, then you need to pay attention already. Okay. Don't worry, but before the test, I will still tell you the scope. I'll tell you the scope of the question. Okay. Then for your test 2, you'll go to test 2, question 1 will cover about phase diagram. You'll see a lot of graph. Then for the diagram, you just answer based on the diagram. Then question number 4, test 2, question 2 will be on the CL4, will be polymer, ceramic, and composite. So this one, if you come to final exam, CL1 will be question 1, CL2 will be question 2, CL3 will be question 3. So it means compulsory 1, 2, 3. Then question 4 and 5, pick 1. So you'll see 5 questions in the final exam. 4 and 5, you pick 1. So question 4, 5 will be, maybe question 4 will be polymer. Question 5 will be ceramic and composite, maybe. So it will choose like 3 of these become one of the question, 4 and 5. Okay. So basically we'll look at, most of the time we'll look at the metals. Then after that, we look at the polymer and ceramic and composite, and a little bit more on the electric, this one. So electrical, electronic, this one I do not cover in the previous January semester, but this semester I will go inside here. Okay. So basically, most of the time I can say 60% of this module will study about metal and alloy. Then other will cover about, including the phase diagram here, will be cover metals. Then the rest is polymer, ceramic, and this one. Okay. Now this module, most of the question I have, most of the question that I ask, if you see question, you will see A, B, and C. A will most probably will be on theory, means you explain based on something. Then B, you do some calculation or analysis. Then C will be questioning how, why, and all this. So this is another high level. You need to explain, for example, you get some value here. Then you need to explain what is this value means to you, right? So for example, you are improving something, give us a scenario, you test, and then give you a scenario, a statement. So you need to explain why you select that kind of material over here. So it will be a theory, or sometimes A and B will combine in one question or one section, meaning you look at the statement, you give one theory, means here you will give a general equation. So general equation, basically you write and then you get a 3 mark already. Then the calculation will be another mark for that. Okay, so A plus B equals C. Then here you do analysis, you substitute value basically. Then here you get a value there. So each question will be 25 marks. So here will be 7 to 8 marks. Here also 7 to 8 marks, and then this one will be a bit more lah. Okay, so total is 25 lah. Okay, basically it will be that. Okay, so but anyway, I will highlight when we come to a specific chapter. So my consultation time will be the lunch hour. So if anything you want to ask me, you just ask me, then text me lah. So later I will add. Okay, today, help me to write your phone number. Maybe beside your name lah, on the left here. So later I'll add you in the WhatsApp group. Okay. So all of you in my room is on the level 5. Level 5, C 122, room number 22. Or you just walk past the lecture room, you see a green screen at my back, then that is my room. Okay. So this is the assessment percentage. So 40% coursework, 60% final. Okay. So you have 2 tasks. One will be in week 7, one will be in week 13. Okay. So test 2, one test for 10%, 10%, also 2 questions, right? Then you have individual assignment here. So basically, this is already secured mark for 10% if you follow the class and you know the answer, right? Lab report will be 10%. So here, if you follow the structures of the lab report, like there's a standard already, right? So more is on your explanation. If you're able to explain what's happening to that one, basically you get at least 8 marks out of 10 here. Okay, you want to do more means you put in reference, you you leave a lot of references, you give a lot of picture features, graph, right? Then you explain, you label correctly. Then most probably you go to 9. You won't rarely see 10 here. Why? Because if I put 10, people will question why you give this student 10. I don't know why. That is the culture. And every time you give a student A, you need to explain why you give this student A. I don't know why. Okay. So, but anyway, I will still, if you are a good student, 9 is okay with it lah. Right? Like the difference only 1 mark now. So yeah. But the final exam here, need to pay attention. This one is 60%. 5 questions, 3 compulsory, and 1 select from question 4 and 5. So you need to get at least 40% out of 100 in final exam. Okay, 40 means every question you get 10 marks, 10 marks, 10 marks. Basically, how you score 10 marks, you know the general equation. That here already 7 marks already, if you know the correct one. No equation will be given in the final exam, so you need to memorize and go into the exam. Okay, so basically you know the general equation, you have marks already, then you substitute correctly. Basically, you can score 10 marks for 1 question already, without even go further. So then you score, maybe you answer 4 or 5 questions, you sure will pass the final exam. Okay, and then what you will see, one question will be on a graph. Graph is the most easy question to score. As long as you draw some lines and then you write the value on the graph. This for final exam or for in your test 2, you need to detach the graph from the question paper. Then you draw something on the graph. Then you explain what happened to that. Okay. Then in total means you combine coursework and final, you need to get at least 50 to pass this module. Okay. Normally student will pass for this module, unless you absent the exam or you didn't do your job. Okay. Okay, so this will be the learning schedule for all the chapter. Okay, so these are the textbook that I'm using along, but in your course structure, maybe only mention the first one and second one, but I use another one. Okay. Okay, so let's go to chapter 1. Okay, so there are some class rules before I go to chapter 1. Class rule is how we define late and absent. So if you come in 10 minutes after we start, then you consider late. After you come in like half an hour, you come in, you consider absent. Okay, but you still can join the class, but I will mark you as absent. Okay. Okay. All right. So chapter 1, we will look at type of material. We'll look at bonding, the comparison, physical, and material selection. So this module, the sequence of the design of the module, we look at the micro structure. This is micro, means you look under microscope, very, very small scale. Then you go into micro scale, macro, means you look at the one that you can see, you can measure. Okay, then you look at a bit on the properties. So micro, then you look at the composite and all this. So you'll see a lot of graph, so on. So at the first, we look at micro, look at the molecule size, then we start to look at bigger and bigger. Okay. Okay, what is the most important thing is the bonding and the material selection. Like, why do you select that material? Because this one later, when you learn in other chapter, this one will help you to make your answer section number 3 in the question. Okay, so this is just an introduction why we study engineering material. So I'll give you one example. I myself, I'm an aerospace engineering in background. So if you want to launch something into the space, you go through a lot of atmosphere, things will get hot. So you need to design a certain material to resist that environment. Okay, including the underwater also. Underwater is pressure, so you need some properties that can handle that environment. Okay. Okay, so these are the things that why we study material. We have certain coating. All these are ceramic advanced material, right? Okay. So we actually chapter 1 or the whole chapter we are answering what material is suitable for that environment and what property that you are looking at. So you look at one properties, then you explain why. Okay. 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 So this is about some history. So from Stone Age, you go for the tools. Basically, when you show you the history of civilization, is you focus on the tools. Early people use rock and then have metals era and so on. Okay. So people use stone to make tools, so on. Then Bronze Age, then Iron Age, people start to make weapon. Okay. The general idea is why people use different material is to make your job become easier and easier. That is the main purpose. Okay. And you will see a lot of this kind of table in this module. You will see the element and then the properties. For example, this is the element of hydrogen, silicon, aluminum, and so on. So for the first chapter 1, 2, 3, you need to recall a table that you learned in your chemistry, which is periodic table. Okay. So once you make friends with the periodic table, you can answer at least 50% of the question in this module. Okay. But we will go into detail when we come to periodic table. Okay. So what are the prospects that you can do if you are interested in material? Most of the time, you are more in the design engineer, because when you design something, you need to, the first thing is your material selection already. Even you do your FYP later, most of the time you need to answer the question why you select that material. Okay. So So this application of the material space exploration, where your equipment need to go through a harsh radiation, materials, and environment, and so on. Okay. Okay. So a new direction of the research nowadays is on the Mars exploration. So if you want to get a job in a material science or material scientist, try to think on the future technology that people are going to use, right? Um, um, the one that I show here is Mars exploration, or you can go and think about something related to biomedical material. Uh, what if another wave of this COVID, right? Maybe COVID version 2 or 3 come. Then if you're good in material, then you can do filtering on the virus. Then you become a rich person already. Okay, so the main idea is you become ready for the future. Okay. Okay, so these are all the characteristics. So what is important here is you will see to explain characteristic, or in the question statement, you will see characteristic of all these light, strong, and then industry, all these. So this one you can read one, I go very fast. Okay, then this is your future job, because nowadays we go into nano material, including nowadays all the computers is getting faster and faster, smaller and smaller, and including your phone, maybe in future is flexible materials, right? So these are the things that we're going to learn later, right? Right. So this is the differences between material science and material engineering. So there's a differences in academic definition. So material science is about the search of basic knowledge, but engineering, okay, material science is that you go and understand the things. But engineering, if you use the word material engineering, means you apply what you learn and then make it uh, into the products that you need. So there's a difference between material science and engineering. Okay, so there's a difference between people studying in Faculty of Science when they study material, and Faculty of Engineering when they study material. There is a difference on that. Okay, so this is a summaries of material science and material engineering. So basically, this is if this one come out in the test one, basically it's a free marks. What you need to do is if you can explain the answer in diagram, then you use diagram. I will not check your grammar, but as long as you use the correct keyword in your answer, then I give you marks already. Okay, so material science and engineering basic combine the two sides of the diagram, science and engineering. Okay. Okay. Now this is a diagram that tell you the relationship between the basic science, material science, and other engineering environment. So you have a 3 cycle there. Outside is the application. Center one is applied science, polymer, and the middle one is the foundation of the materials. Okay. So the rest you read lah. Okay. So this the purpose of the first class is to let you differentiate what is the difference of material science and engineering. Okay. Okay, the rest you can read. These are the important properties that we'll go through throughout the rest of the lecture. The first one, mechanical properties, because you are from mechanical engineering, you're doing degree in mechanical engineering, we will focus heavily on the mechanical properties. All right. So mechanical properties link with the load and force. So equation that link to the word F, force, you need to be very good. Anything that related to force or pressure. Load can be the word load. Load, it can be force in Newton, or it can be pressure in Pascal or Newton over meter. Okay, so you need to be careful on the question. Sometimes the question just use the word loading, and then you read the question, whether the question asks you to answer in force or in pressure. Okay. Then electrical properties, this one will be in the last chapter of this module. We apply to the electric field, the Ohm's law. Okay, that what you learn in your other module, you just apply here. Thermal properties, this one is the temperature. This one will not be the focus of this module, but you will look at the effect of temperature at the phase diagram later, right? And the phase diagram, there's I think CL2 or CL3, I forget already, that asks you to look carefully on the phase diagram. Phase diagram will link to the thermal properties. Okay. So magnetic properties, this one is more on the magnetic field. This one will not be in our module. Optical properties, this one also will not in our module, but you can relate this 1, 2, 3, 4, 5 in your lab report. You can elaborate the lab report in this 1, 2, 3, 4, 5 area. Okay. There's one more. This one is on the corrosion, deteriorative characteristics. This one is in other subject taught by Dr. Yuli. Right, corrosion. I think you haven't taken that module yet, but I will focus heavily on the corrosion characteristics. Okay, so this diagram is tell you that this actually is the same same diagram, same material. This one is okay. They have three types of optical description. One is transparent. What I mean by transparent, the light can go through. Right. Translucent is between the opaque and transparent. You can see through a little bit, but not very clear. So there are three types of optical properties. Okay, transparent, translucent, and opaque. Right. So this one is aluminum oxide. Three of these, they are aluminum oxide, but they behave differently on the optical properties. This one related to the way of manufacturing and the way of your curing the material. Okay, so this diagram usually come out in the section A of the question. It will ask you to tell the relationship of processing, structure, properties, and performance. Some question ask you about processing. Some will look at structure. Some are properties and performance. So processing will be one of the chapter. Structure will be in chapter 2, more on the molecular. And properties will be in chapter 3 or chapter 4 when it comes to mechanical properties. Performance is on the application. This one, it will be on the section C of the question. So you will link structure to performance, properties to performance. And sometimes you back to the performance, it will tell you what are the processing steps that you need to do, like how you process the things. So this diagram, it will guide us how we set the question. Okay. Okay. So for this module, we'll look at three types of materials. So fundamental or main classes: metallic, polymeric, and ceramic material. Metallic means metal. The base word is metal. Polymerics means the polymer. You learn in your SPM, right? How to form rubber and all this. So ceramic is a mixture of two kind of materials, right? So how you differentiate them is through mechanical, electrical, and physical properties. So there are some graph there. There's some graph there. So there's some composite material and electronics materials. So the rest you read now. So this is a important graph that maybe I think this one also in the canvas, there is a periodic table there. Okay. So this is a periodic table that is important. Maybe I explain a little bit on here. So just a recap, just a recap. How you know? Let me see if any marking there. Okay. So periodic table you can you can read by column and row. Okay. So you have family 1, family 2, family 3, 4, 5, 6, 7, and then 8. Then the colored one later you will see in the next chapter. What is important is you understand that there is a different family on the table here. There's a meaning of the one they put it here. Later, when you look deeper in the periodic table, I will explain. Okay, and as you go deeper, it means that it's a different orbit that you have. Okay, now the column one, like for example, family number 1, it means outside. If you look at the molecule, it means you have 1 electron. Outside means it's fall under family 1. If you have 2 electron outside means it fall into family number 2, and so on. Okay. Then usually on the left hand side, they are all metals. On the right hand side, they are non-metals. So you need to form a stable materials when it comes to chapter 2 or chapter 3. How you form? Usually you take this one plus this one. So you get the number 8 in your outside molecule, outside electron. So how you combine a stable one? You take this one, family 1, and combine with family number 7, 2 with 6, and so on. As long as you get a stable composition, then that is your objective. Okay. Then just now we explained about the column. What happened to the row? Row means the first one, row here. The first row means you only have 1 orbit. Then you go down, this is number 2, means you have 2 orbit. It's like two orbit in the molecule, and so on. Okay. Later we'll go deep inside the molecule. Okay, so these are all I use the word highway. So highway number 1, number 2, but inside highway you have different lane. So later we'll go deep into this one in the later chapter. If this kind of question come out, sometimes you don't need to know the for this module, you don't need to write the full chemical name, but you're referring to the alphabet that you see in the periodic table. Okay, because we are not really material scientists, we are apply the material. So as long as you write properly the chemical alphabet, then you are okay. Right. Now we start with the definition of metallic materials. Metallic materials. So what is the metallic materials? So sometime this one will be in the section A of the question. It's a theory based. So ask you to define a metallic material. So what does it mean? It means they are inorganic substance that combine with 1 or more metallic elements, may also contain some metallic metals element. Okay. So example, iron, copper, this one, right? Now, normally the question will ask you to give a few examples. If the means the answer, you just need to memorize 3 examples from the PowerPoint slides. For example, give you example. If the question asks you, give a few example of the material elements. Give 3 answer or 3 examples. So you need to memorize 3. Okay. Okay. So this is just a recap of what you learned in your chemistry class. So iron, Fe, copper, aluminium. Okay. So when you have the proper detailed periodic table, you'll see all these number. Okay, you'll see all these number. So all these number later they also have a calculation for these numbers. to prove that, okay, periodic table showing the correct numbers. Nickels, titanium, and so on. Okay, so non-metallics elements, carbon, nitrogen, oxygen may also contain in the metallic materials. Nitrogen, oxygen. So these carbon, nitrogen, oxygen, they are the very popular element in this module because you can combine them to form another type of new material. Okay, the popular material for this module also all these 5 main ingredient: iron, copper, aluminum, nickel, and titanium. Okay, so in other chapter, when come to phase diagram, you will see also these 5 main element. Okay. So metals, you know, they are good thermal conductor and electric conductor. So in your lab, there will be one experiment to test the thermal conductivity of the material. So there's one experiment. You put the wax. You put a wax here, and then you put a nail here. Then you use a different rod. So this rod, it can be aluminum, it can be copper. Okay. Then you hold it with the red dot. Okay. Then you burn it at one end. So the heat will come from here. Once you put it here, you start the clock. Okay, you start the clock. Then when this one drop, I mean you measure the distance. Then you start the clock. When this one drop, you have the time and you have the length. Then there's an equation to calculate the thermal transfer equation. So this is one of the lab experiment. Okay. Okay. So metals and alloy. So metal means pure metals. Alloy means there's a combination of different metals. Okay. So 2 class, if you have a ferrous metals, ferrous Fe, it means it contain large percentage of iron in the combination. Non-ferrous alloy means they do not contain iron and relatively small amount of iron. For example, aluminum. Aluminum, they are not, they don't have Fe, but they are non-ferrous materials. Okay, so these are the main 2 big family inside metallic alloy. Okay, copper, zinc also, nickel also. Okay, now nickel is important when it comes to a later chapter. We talk about composite. Okay. So this is more on the engine. So engine parts also, different parts have different type of material because the environment, you need to resist high temperature and also different pressure inside there. Okay, one turbine blade is nearly to one X7, our national car. One blade is about one car price. So one turbine here is you can buy a few bungalow. Okay. Okay. Now just now we talk about metallic materials. Then we go into polymeric. Polymeric, the word polymeric means you have a long chain and then you combine with an organics combination. Most of the time you have a carbon inside there, right? So the rest you read. So later there's a later chapter when you go into polymeric, then we'll go into what is non-crystallized material and so on. Properties in a polymeric material, you can you can just memorize it as a rubber material. So rubber, they easily melt away when you raise the temperature. Okay, so low density and they soften or decompose at the low temperature. The rest you read. There's a poor conductor and electricity. So basically, later you'll see a graph that explain all the material properties. Okay. So we'll look at there's one particular chapter about polymeric. So I won't go deep into this one, but this is what you're familiar in your SPM examination. You learn about this rubber polymerization process. Okay. Right. Okay. So this again, you see a periodic table again. Right. So the one that have in the color, in the blue color here, is highlighted because they are used in the commercial polymer. So commercial polymer is a combination of CNOF, Si, and hydrogen. So different percentage of all these elements will give you different names of polymer. So these are all the example lah. Okay, nowadays we don't use this one anymore. And all the rubbers, shoes, and all this. We'll go deep when you come to polymer chapter. Okay. And why polymer is important? Because Malaysia, we are producing a lot of rubber, raw materials. So it's one of our economic growth. So this is a Malaysia rubber production. This one I take from a Malaysia Rubber Council. All this data you can read later. Okay, this one is up to last year, March. So we export a lot of rubber material to China, right, and the rest of the world, right. So these are the rubber that we are producing: natural rubber, synthetic, and so on. Okay, of course I won't ask you this question. I just give you some exposure. What is our position when we come to rubber products as a Malaysian, right? All this you do. Glove I mentioned here because one of the top employer in Malaysia is Top Glove. So and you have if you want to do internship with them, then you should know a little bit on the polymer chapter. Okay. Okay, ceramic materials, basically they are non-organic and they consist of metal and non-metal that bond chemically. So these are the definition for ceramic materials. Okay, so the rest you read. So what mean by crystalline? Crystalline is what you see at the diagram here, means you're able to see a repeating pattern in the microstructure, crystalline. Non-crystalline means you are unable to predict how they do it, right? Okay. So this one you read. So this one is a fiberglass video. Okay. So I won't. Maybe you can view this video when you have in your free time. Okay. Why this is important? Because this will be the material that we will be using when you graduate and you work in the field, right? All the telecommunication start to use fiberglass in the application already. And if you're very good in this area, you also can make a lot of money, right? Because nowadays we still use wireless signal, but in future we might be using light as our data transferring instruments. Okay. Okay. So I make the rest you read. Hardness. They have a high hardness. They can withstand high temperature, but they are brittles. Right. They're not very good in compacting stress or force. Right. So there are two types of ceramic. Traditional is the one that you look the crepe products, and nowadays we are go into advanced engineering ceramic that used in manufacturing and also in medical nowadays already. Okay. Why use ceramic good in biomedics? Because our blood contain iron. So if you have this ceramic, then it's able to resist the corrosion inside our bodies. And also our body have acidic properties. So if you use ceramic in our bodies, then you will be able to sustain life. Okay. Right. You will see this kind of graph in the test where you are given a few colors there. So you see metallic element will be in the light blue color, non-metallic in the dark blue color. Okay, these 5 elements here. Okay, so you'll be seeing H most of the time. Why hydrogen is not metals, but they are on the top? Because hydrogen, they have a very special properties. Okay, so the rest you read. Advantages also you read. So this one again, this slide is important when it comes to question section A. It will tell you, okay, give advantages of using ceramic materials or advantages of using metallic materials and so on. Okay, so this one you read lah. These are the example of ceramic materials on the aircraft. Nowadays you see all this shape and all this. Okay. Composite, they consist of 2 or more materials, right? Or more materials. Okay. Now, there is a specific chapter about composite materials. Basically, when answering question on composite materials, you need to highlight the 3 elements: filament or fiber, matrix, and the products. Products is called composite. So you take A plus B, you get C. The calculation on here plus this one, you get, so there's a calculation. So on the composite, it depends on the main ingredient. So if you use a lot of metal, you will know as metal matrix composite MMC. If you use lots of ceramic, then it becomes CNC. If you use polymer, then it becomes CNC. The rest you read. This one also you read. This one just the application of materials on an aircraft, where they use it on car also. This one under microscope, how it should look like. So you will see all these picture when it comes to lab report. You use this snapshot also in your lab using microscope. Semiconductor, you know semiconductor, you also learn this one in your SPM. Semiconductor means it's able to become insulator or also conductor, depend on the environment they have. It can become resistor, it can become conductor. Okay, so they also highlight the ingredient that usually used for semiconductor. Recent advance of materials, smart material. Smart material means they're able to sense the environment, then react to it. So sensor, definition of sensor means they're able to detect. Actuator means they're able to have a response, mechanical response. So the one here is on the heart surgery. They use the spring as a smart material. So even you work in this company that producing this one, also you can make a very good money, especially become the salesperson. Right? Because this one you want to they must use this one already in the operation. So if you're selling necessary accessory, then you're not worried about that. We need to consider the competition, because not only one company. Right? Smart materials, MEMs. So nowadays, all the electronics really use a very, very small size of sensors. Okay. So this diagram is for the automotive airbags, the sensor. They built in very small and they're able to release or burn the materials when there is an impact there. So these are the MAM sensor in automotive nowadays. We have our highly intelligent car already. So we have all lots of different sensor. So all these sensor, they are using materials. Nano material, nano means 10 power 9, negative 9. So anything that fall smaller than 10 negative 9 meter, they are under nano materials. Okay. Or you read lah. Okay. So I'll go show you a few graphs. Then I think we call it a day. Then we continue in the afternoon. Okay. Now, this is the chart of temperature density. See on the left hand side. Here is maybe I need to turn the difference. It's a temperature on the left hand side here. Density on the left hand side. Density, the density, the left hand side. So it just gives you a graphical idea on metal, ceramic, polymer, and composite. So again, this module focus on these four main elements: metal, ceramic, polymer, composite. Then you explain them through the properties. Then they tell the selection of material is actually from all these graphs. Okay, so metals, they actually have a very high density compared to composite. Means they're able to compact, right? So composite a bit lighter compared to this one. Ceramic will be in the middle, polymer will be in the middle. Okay. So the rest you read now, my slides. Okay, next slide. This one is on the room temperature of their stiffness. Stiffness is ability to cool, elongate. So you can see metals is quite high compared to polymer. Polymer, you can they easily break when you have a high force, like rubber, you pull at a certain force, they will break. But metals, they're able to withstand, right, a high force. Ceramic also, composite also. So for example, ceramic, you can imagine as the bulletproof vest. So you use ceramic because they're able to withstand a high impact force. So, okay, the next graph is on the tensile strength. This one on the tensile strength. We're able to pull. Okay, so just recap in your finite element of forces. So forces, there are a few forces. If the arrow pointing both end outside, they call tensile. The force is pulling outside, or force or pressure. Can be pressure, can be force, but the arrow pulling outside, it means tensile. Then inside one is compression. Compressive or compression. Okay. Then if there's twist, it means torsion, and so on. Okay. As you read. Next one, this one is resistant to fracture. Resistant to fracture. Also you read. This one is the electric conductivity. Metals is very high compared to ceramic and polymer. Semiconductor at the middle. This one is on the conductivity of electric and temperature. Okay, this one is on the. This one also is it. Okay. So material selection also. Let me see. Can we finish a bit early? Maybe you stop here. We continue afternoon.